In this video I have brought you a very nice and interesting problem of Australian Mathematical Olympiad edition 2016. In fact, this is very nice problem, so I would like to introduce a very nice proof. Our goal, we are not going to solve this equation, we are going to prove A equals B. Okay, so by the way you are going to solve the equation, in the way you are going to figure out where we have equality, we are going to use a such proof in order to prove this one cannot be written as a power of 2 if you have A not equal to B. Okay, I'm going to assume A not equal to B, then at the end of the term we will find the contradiction. This is the proof that I'm going through. Okay, so without loss of generality, assume A is strictly inferior than B. Okay, let's set B equals A plus R, where is R is a some natural number. Okay, this is the relationship between A and B. As you know, this is factorable polynomial, is written on the form of A cubed plus B cubed, which means it's going to be written on this form: A plus B factor A square minus AB plus B square equals 2 to this, like this. Okay, first of all I would like to go through these cases when we have A equals 1 and B equals 2. I'm gonna tell you in 1 second why I'm doing this one. Okay, so A equals 1, replacing this information into the original equation, I get here 1 cubed plus 2 cubed, which is given as 8, 9 equals 2 to this. This is not a power of 2, which is impossible. So which means we have a contradiction at the point A equals 1 and B equals 2. Let's work on this one now. Since the right hand side of this equation is a power of 2, which means the left hand side of this equation is a power of 2 as well. Okay, which means I'm going to transfer this one into the equation system. We'll have A plus B equals 2 to the I. Second equation, you get A square minus AB plus B square equals 2 to the J, where J is strictly superior than I. But which condition this one is verifying? On this condition, when we have A is strictly inferior than A is strictly inferior than B. Okay, we already checked A equals 1, B equals 2, didn't work. Okay, so which means I'm going to study this one on this interval. So this one is verifying this condition, because if you replace A with number 2 and B with number 3, this one is valid for all this interval. We will have J strictly superior than I. This condition is very important. Okay, now I'm going to make some motivation here, so in order to cancel out A square B square with this one, so I'm going to raise number 2 as a power in first equation. I get here A plus B quinary square equals A square plus 2AB plus B square equals 2 to the 2I, like this. Second equation, I get here A square minus AB plus B square equals 2 to the J. Now I'm going to put this equation minus this equation, so I will have a lot of cancellation here. I get here A square cancelled out, B square cancelled out, I get 2AB minus AB, which is 3AB. I get 3AB equals 2 to the 2I minus 2 to the J. J strictly superior than I, but 2I is strictly superior than J. Okay, you can check it in this first equation. This one is bigger than this one, which means this one is bigger than this one, which means 2I is bigger than 2J. Since 2I is bigger than J, I'm going to take 2 to the J as a common factor. So we'll have 2 to the J factor to the 2I minus J minus number 1. Okay, now we are going to break this one into two cases. When we have A is a odd, and when we have A is a even. Let's consider the first case. If is a odd, if A is a odd, B must be odd as well, because odd plus odd is given as even. And also remember, if A is a odd, we know B is a odd, this one must be even, R must be even in this case. Okay, this is odd, this is also is odd. Okay, Now I'm going to replace this fact into this one. I get here 3 is multiplied by a is multiplied by e plus r equals 2 to the j is multiplied by 2 to the 2i minus j minus number 1. Okay, we know this is odd. We know a is a odd, this one is a even, this one is a odd, which means the whole thing is a odd. We know the left side is odd, the right side is even, which is impossible, which is a contradiction. Okay, and also remember, since j, if you go back to this equation, you find j is always strictly superior than 1. Okay, since j is strictly superior than 1, this is impossible to have odd equals even. Okay, this is even, which is contradiction. Now we have created a contradiction on odd number. What does mean contradiction? We have contradiction or assumption, which means a not strictly superior than b. Now let's clean up this board and move on to the next case when we have a is a even. That case, it will be a challenged case. We'll have to have a lot of work there, because the even it makes us a problem, because the evenness becomes a problem in this equation. When we have a is a even, okay, b must be even as well, because we have 2 to the c is a even. If b is a even and we have a is a even, r must be even. Okay, so now have r is always even, a is a even, b is a even. Okay, here is a problem. We have the whole left side is a even, because this term is a even, this term is a even, this term is a even, this one is a odd. We number 3 is a odd. We cannot say 3 equals to this one. If you believe this one equals to this one, are going to show this one is not carrying any prime factor. Okay, we are going to go through the absurd proof. We are going to assume we have odd factor, then we will find impossible to have a odd factor for this equation. Okay, so by the way of contradiction, suppose d divide a is multiplied by e plus r. Okay, with d is a odd, because we are considering this one has an odd factor. Okay, so if you take a look carefully at this term, since this term is a even, this one is a even, which means the product of these two numbers is going to be divisible by a number 4. Okay, which means the right hand side of this equation must be divisible by number 4. This one is telling us 4 divides a is multiplied by e plus r. This implies, because this one is a even, this one is a even, the product of two even numbers is always divisible by number 4. Since they are divisible, since it is divisible by number 4, which means the right hand side of this equation is divisible by number 4. But this one is an odd, is not divisible by number 4, which means this term 2 to the j is divisible by number 4. So one is telling us 4 divides 2 to the j. If 4 divides 2 to the j, which means j is always superior to 2. Okay, then the second thing that I'm going to mention here, this term, since it has an odd factor and the right hand side of this equation it seems has a power of 2 here, then this term must be written on this form. A is multiplied by e plus r equals 2 to the m is multiplied by d, like this. Okay. Because with m is superior to 2, because at least we have number 4 here as a power, because we have product of two even numbers. So I'm going to build our proof on this one. So by replacing this one into this one to see what's given us, I get here 3 is multiplied by 2 to the m is multiplied by d equals 2 to the j is multiplied by 2 to the 2I minus j minus number 1. I'm going to divide both sides by 2 to the m. We know m is superior to 2, okay? I will have the following. I will have 3d equals 2 to the j minus m factor 2 to the 2I minus j minus number 1, like this. As we know, this is odd. By assumption, this is odd. We have the product, the left hand side of this equation is a odd. The right hand side of this equation, this one is a odd. But this one is a even. It's impossible to keep this equation like this. So since this one is a odd, the left is a odd, which means this one must be equals 1, which means the exponent must be equal to 0. So when it's telling us j minus m must be equal to 0 in order to get 2 to the j minus m cancelled out. In the other word, j equals m. So we know this number is not divisible by d, but this one is divisible by d, okay? Because this one is odd, this one is odd. Which means I get 2 to the 2I minus j minus 1 is a congruent to 0 mod d. Okay? In the other word, I'm going to take this minus 1 to the right. I will get 2 to the 2I minus j is a congruent to 1 mod d. Okay? Here is two cases. If this one is a odd, I'm going to take off this exponent. This one becomes 2 to the becomes 2 is a congruent to 1 mod d. In the other word, I get 2 minus 1, which is 1 is a congruent to 0 mod d, which means d divides 1. If d divides 1, which means d equals 1. This is one case, very nice, okay? But the problem, if you have this exponent is a even, if this exponent is a even, I'm going to change it just here. If this exponent is a even, which means j is a even, okay? If j is a even, I will have two cases here. I will have after taking off this exponent, I will have two cases. I will have 2 is a congruent to plus or minus 1 mod d, okay? So we already proven the case when we have 2 is a congruent to 1 mod d, we found d equals 1. But let's consider the case when we have 2 is a congruent to minus 1 mod d. I'm going to take this minus 1 to the left. I get 2 plus 1, which equals 3 is a congruent to 0 mod d, which means d divides 3. If d divides 3, which means d equals 3, okay? Take this value and insert it into the original equation to see what's given us, okay? I'm going to put it here. So we'll have 3 is multiplied by 3, which is 9. I get here 9. As we said, this one, it was 1. So this one equals 2 to the 2I minus j minus 1, okay? I'm going to take this minus 1 to the left. I get 10 equals 5 is multiplied by 2 equals to this term, 2 to the 2I minus j. So I'm going to cancel out one of the 2 from here. I get here 5 equals to the 2I minus j minus number 1, okay? But the problem, this is even, but this one is odd. It's clearly is a contradiction, okay? What we have contradicted our assumption, because we assumed we have a prime factor, which means d divides this term, which is impossible. So which means we have no odd factor is strictly superior than, which means we have no odd prime or odd factor, okay? Now I'm going to clean up this board and move on to the next case. So previously we were fighting against this one to prove we don't have the odd prime here or odd factor. We have proven that. Now I'm absolutely free to put 3 equals to the 2i minus j minus number 1, and the whole term, which is even, a is multiplied by a plus r, equals 2 to the j. So why I'm putting this one on this form? Because I know this product, this term which is even, doesn't have odd factor. Okay, so which means the odd goes to the odd, even goes to the even. That's what happened here. Whole evenness goes towards this power, 2 to the j. Now I'm simply going to solve this first equation. I get here 2 to the 2i minus j equals 3 minus 1, which is 4. 4, it will be written on this form, 2 square. I'm going to take this exponent equals to this one. Okay, so I will have 2 to the I minus j equals 2. In the other word, 2 to I minus j equals 2. I have very nice relationship between this one and this one. I'm going to work on this one now by replacing j with its value. So we'll have 2 to the j, j will be replaced with 2, I minus 2. Because I'm bringing this 2 to the left, j to the right. I'm going to factor out this one on this form, 2 to the I minus 1, like this. By putting 2 as a common factor and raise this one as a power as well in the same time. So I have a is multiplied by a plus r equals 2 to the I minus 1 square. Since I get to this expression, a plus r, it will be replaced with b as you see it here, because by assumption we put b equals a plus r, right? This one is telling us number 2 is a power of a and b. Okay, since 2 is a power of a, I'm going to write a on this form, a equals 2 to the k, like this. Okay, at the same time I'm going to distribute this one, so I get here e square plus er equals 2 to the I minus 1 quantity square. Then I'm going to move over this e square to the right and leave er to the left. So we'll have er equals 2 to the e minus 1 quantity square minus e square. So I have a difference of 2 squares. I'm going to factor out this one on the form of the product. I will get 2 to the I minus number 1 minus a factor 2 to the I minus 1 plus a, like this. Okay, since we have a is a power of 2 to the k, since we have a is a power of 2, I'm going to replace this value of a into a. Okay, so we'll get here 2 to the I minus 1 minus 2 to the k factor 2 to the I minus 1 plus 2 to the k, like this. And I'm going to replace also a with 2 to the k, like this. Then I'm going to take 2 to the k as a common factor. I get here 2 to the k is multiplied by r equals 2 to the k factor 2 to the I minus 1 minus k minus number 1 factor 2 to the I minus 1 minus k plus number 1. Then I get 2 to the k cancelled out from the left and the right. Keep in mind k is always super equal to 1 because k is an even. Okay, then if you take a look carefully here, this is odd, this is odd, but this is even by assumption, because we have assumed r was even. By the way, b was even, a was even. Okay, but this one we have 3 cases here, so we are going to compare I minus 1 and k to see all the 3 cases what's the change in here. You may have some changing. So if I minus 1 equals k, if I minus 1 equals k, which means this one turns into 0. If the exponent is 0, it becomes 1 here. 1 minus 1 is 0. 0 is multiplied this one is given as 0, which is impossible because we have r as an even integer, which is r is super equal to 2. This is impossible. If you have a minus 1 is strictly superior than k, if I minus 1 is strictly superior than k, which this one, it's clearly is odd because this one is bigger than this one, the exponent is growing up, minus number 1 is always giving you as odd. This one is also is odd. Since we have odd is multiplied by odd, is given as odd, but the left hand side of this equation is even, which is also is impossible. Let's consider if I minus 1 strictly inferior than k. Okay, if I minus 1 is strictly inferior than k, which means this exponent become negative. This is negative, this number becomes not integer. Okay, it's a contradiction. So for all these three cases is indicated we have a big contradiction here, which means in fact there is one case left because we assume just a strictly inferior than b, but by symmetry reason we don't need another case. This is enough. This one is covering the other case, which means this one exactly a must be equals b. Okay, so I will undo this video. If you have any question or suggestions, just put it in the comment section below. Don't forget to support us with a like and subscribe. Thank you for watching. I will see you next video. Bye.